so warm up 109 for today. We have number 1, graph the circle, and it gives us x squared plus y squared plus 12y minus 14x plus 4 equals 0. Number 2, it says simplify, use long division. They give us the fraction 5x minus 9 over x minus 2. Number 3 says simplify the log. They give us log base 2 and the given number 32. And number 4, it says compute the missing length of the triangle, then identify cosine of angle A. So they give us a right triangle. They give us C at the right angle of that triangle. And then we got A on one side, B on the other. And then we have sides 8, which is on the side length CA, and 15 on the side length CB or BC. So basically we need to figure out what BA is, or the hypotenuse first, and then identify the cosine of A. All right, so with that said, copy that, and we'll get started in a little bit. All right, here we go. Number 1, we need a center and a radius. Center and radius. Let's see. Leo? Oh, no, he wasn't here yesterday. Oh, but he's got this. Leo, what'd you get? Center and radius. Center and radius. 7 and negative 6? 9. Hands if you got that? That is correct. So therefore, that graph, 7 is here, negative 6 is here. That's our center. 9 of the radius, that means it's going 3 this way, aside from the 6, so that's 9. And then 2 this way, and then 9 this way, 9 this way, and there's our circle. Okay? All right, hands if you got that once again. Okay, pass someone, Leo. Pablo, what'd you get for this one? Hands if you got that. That is correct. Once you do the long division, the quotient is 5, and then the remainder was 1, and then since this was over here, we just moved it to the back. Okay? And reminder, what is the only thing, or what is the only number that can stay on the numerator? A positive 1. Anything else has to go to the front as a coefficient. All right, pass someone. Who? All right, y equals 5. Okay, I'll take y equals 5. So basically he wrote this as y equals log 2 32. Then he rewrote this as 2 to the y equals 32. Oh, sorry. (32), and then he wrote 32 in base 2, so 2 to the y equals 2 to the 5th. So therefore, y equals 5. All right. And what did we get for x? Pass someone, Justin. X equals 17 units. That is correct. All right, so you find out by a squared plus b squared equals c squared. Notice I haven't moved the x from the hypotenuse yet. I might do that tomorrow. So this is our long side. So now we want cosine angle A. Pass someone. Cosine angle A. Sebastian. 15 over what? What? 15 over 17. Okay, so we're looking at cosine. Cosine is adjacent over hypotenuse. Adjacent meaning right. 8 over 17. Hands if you got that. That is correct. All right, copy the agenda for today. We got warm-up number 109. We're continuing on with semester 2 concepts and skills. Tonight, once again, you're going to study. Yesterday was to study, but numbers what through what? 1 through 5, yes? Tonight's going to be, I think we're only going to get through 2 problems. Can you believe that? We're like, what? I know, right? So, tonight, when you get home, you're going to do the 2 problems that we do here in class again. Why? We want to make sure we get the process correctly. Try not to look at your notes. Check your answers. If you get it right, you're good. If you want to do it again just for practice, that's fine. But if you get it wrong, check where you made a mistake and redo it. Okay? All right. So, your home plate from last night, once again, was problems numbers 1 through 5. Go to Canvas at this time. Turn that in. Now, this is what I want from you. Take a picture of the whole page where you did the work, numbers 1 through 5, and submit that. It's only 500 points. I don't want problems by themselves. I just want to see the entire page, which means shouldn't have anything we did in class, right? Okay, good. So turn that in at this time, and then get a blank sheet of paper of Cornell notes. You don't need a Frayer model. Now, just the purpose, so that it's recorded again on video, the purpose of practicing is because I want you guys to pass this final. 25% of your grade. 25%. 25%. Tell you how many letter grades? About 2 letter grades, right? All right. Just checking. All right. I'll give you time for that. In the meantime, there's the objective. Those of you that are already submitted your home plate, copy the objective. I'm going to pause this for a little bit quick and continue. All right, so our objective for today, I can master all semester 2 concepts and skills. We're going to continue with a study guide today. And let's see where we've been. We covered circles. We covered, what else? Parabolas, yes. And then we got to systems. That's where we left off. And the last problem on systems was this one. Look up to the screen. There it is. And it shows us that we have a linear equation and a quadratic equation, and we use substitution to solve. We substitute this equation in here, so it gave us this, set it equal to 0, factored, solve for x, then we wrote x's in parentheses each. We substituted the x values into the original, which was the first equation, and we found the values there for the y for both. And what did we say these 2 points were? The solutions is where both graphs intersect. So this is the quadratic, this is the linear, and this is where they intersect. Okay? So how many points? 2 of them. Okay. So far so good? Yes? So that is linear, 2 variables, 2 equations. Copy this one, example 6Q. Moving on to 3 variables and 3 equations. Yay, let's go. Now, once again, one recommendation for you to have, if you have your highlighters, have those ready. If you have your colored pens, have those ready. In case you don't have a highlighter, you can underline each equation with a different color. And I'm going to revisit this systems of equations in 3D. And to start off, I'm going to use my highlighters to highlight each of the equations. The first one, I'm going to do that in green. The second one in pink. And the third one in yellow. Now, why am I doing that? Remember when we got to these? Because we're going to combine 2 of the equations with 1 twice. We're going to use that one equation twice, one for one equation, one for the other equation. But before we do that, we need to look at the 3 equations and figure out, because the first step is to eliminate one of the variables for all 3 of them. Look at the 3 equations. Look at the 3 variables straight down. Which variable would you think would be the easiest to eliminate from all 3? Talk it over your neighbor. Let them know which variable is going to be the easiest to eliminate from all 3. by looking at it. All right, I think Mario's got it. Mario, go. Which one? The first one, what? All right, stay focused, please. Diego, what do you think? Which variable? He said the third one. Why? Why do you think he said the third variable, which is z? Look at it. Because these are going to eliminate right away. Do you guys see that? Z minus z, they cancel. But to eliminate these right here, what does this one need to be? -3, right? To eliminate like this. So this is what I'm going to do. I'm going to write this one right here. And right below it, I'm going to write the pink one. And then right next to it over here, I'm going to write the yellow one, but also with the pink one. Because I need to use this one for that one and this one for this one. Yes? So let's write those equations. I'm going to use black. I'm going to rewrite this one here. X plus 2y plus z equals 8. And right below it, 2x plus y minus z equals 4. So this one again here, 2x plus y minus z equals 4. And the yellow one is x plus y plus 3z equals 7. Okay, so Diego said let's eliminate z. So with blue, so we can show that here, we're going to combine the two equations. Let's start with z. What is z minus z? 0. Z. You guys, no? Okay. Anything? No? Okay. X plus 2x is 3x. 2y plus 1y is 3y. And 8 plus 4 is 12. Okay, so we're going to leave that for right now. Let's go to this one over here. We need to eliminate the same variable. Can we eliminate the z's right now? No, so what do we need to multiply this entire equation down here so that it can be -3z? Times 3, yes, times 3. So 3 times 2, that's 6x. 3 times y, that's 3y. 3 times -z is -3z. And 3 times 4 is 12. Use a different color so you can get rid of this one so you don't get distracted. So we just focus on these two, and now we eliminate z. 3z minus 3z, they cancel. 6x plus x, that's 7x. Y plus 3y is 4y. And 12 plus 7, that's 19. All right. And some of you are like, I think I remember, Mr. Q, but what is the purpose of getting rid of 1, Mr. Q? Because now we have two smaller equations. And now we can actually make a smaller system. 3x plus 3y equals 12. And 7x plus 4y equals 19. Now, for the purpose of right now, I'm not going to use substitution. I'm going to continue with the elimination method, which is what we did here. So look at it. Can we eliminate the x's? No, they need to be the same coefficient. How about the y's? No. So at this point, it doesn't matter which one we eliminate, but we need to transform it before we do. So tell your neighbor, which one do you want to eliminate, the x variable or the y variable? Which one would you eliminate? All right, Daniel, which one? He said x. So if we eliminate x, look at this. Let's treat the 3 and the 7 as denominators. 3 and 7. What would be a common denominator? 21. Okay? So let's eliminate x just for the sake of that. So to make this one into 21, what do we need to multiply the top one by? 7. So we distribute. That gives us 21x plus 21y equals 84. All right. So since we're eliminating the x, this one has to be 21 but a negative, right? So what do we need to multiply this one by? Negative 3. So negative 3 times 7, that's negative 21x. Negative 3 times 4, that's negative 12y. And negative 3 times 19, that's negative, 19 times 3 is 57. And now we can eliminate. 21 minus 21, they cancel. What is 21 minus 12? 9y equals. What is 84 minus 57? 27, yes. And then to finalize that, we divide by 9. So y equals 3. So for this little system, we need to solve now for x. Is that correct? So Fatima, which one do you want to use, the blue one or the red one? The red one, okay. Does it matter? No. Just substitute into any. So I'm going to rewrite this one right here. But instead of y, what am I going to do? I'm going to substitute what? 3. So I'm going to write negative 21x minus 12 times parentheses equals negative 57. So I substitute in there the 3. So I end up with negative 21x minus 36 equals negative 57. Continue, Kevin. What do I do from there? Plus 36 plus 36, negative 21x equals negative 21. And last but not least, divide by negative 21, divide by negative 21, x equals 1. So we have solved this little system, but which variable are we still missing to solve? Z. Which equation do we want to use, Mel? The first, second, or third? Last one? All right, so I'm going to bring this one, and I'm going to write x plus parentheses plus 3 parentheses equals 7. And instead of y, I'm going to substitute 3. And instead of x, oh, sorry. I put the parentheses for z instead of x, sorry. 1, 3, and this is z. Okay. So we end up with, what is 1 plus 3? That's 4 plus 3z equals 7. Next. Okay, you go. Minus 4 minus 4. 3z equals 3. Divide by 3. Z equals 1. Are we done? Yes. So we open up our parentheses. We start with x is what? 1, and then 3, and then 1, and these are my, or this is my solution. Tell your neighbor what that means. What does this mean? Talk it over your neighbor, let them know what that means. All right, what does that mean, Mel? Did we hear that? That's where all three graphs will intersect. When you graph all three of them, that's the point that they are going to intersect. It's only one point. All right. So here goes the process one more time. What did we do first? We changed the color for all three of them so we can keep organized, and then think, which variable am I going to eliminate to start with for all three? We didn't go with x. We went with z. Could we have started with x? Yes. Just rewrote them and then cancel the x's by changing one of them. Same thing for the other, and so on and so forth. All right. So copy this one. Example 6s. We got 2x plus 3y plus z equals 27. Then we got x plus 5y minus 3z equals 52. And negative 3x plus y plus 2z equals negative 16. Okay? So, once again, if you have your three colors, I'm going to start with the top one in green, the middle one in pink, the bottom one in yellow. If you have colored pens, then use three different colors just to underline each equation and stay organized. Okay, I'm just going to get you guys started. Here goes. Look at all three of them. And look all three variables straight down. Which variable would be the easiest to eliminate from all three? Talk it over to your neighbor. Let them know which would be the easiest to eliminate from all three. All right, good conversations. Edwin, which one? Z, okay. So if we eliminate Z, that means when we write these over here, this one has to be a what? A 3, yes. And these, we're going to have to multiply both of them. Okay, yeah, we can do that. But it'll be a lot of work. Which other variable did you select? What do you think, Kevin? X. That's fine. To eliminate these two, all we need to do is multiply this equation times what? Negative 2. And then to eliminate these two right here, this will be multiplied again times what? Times 3. So yeah, I think to eliminate x, will that work? Yes. Okay, so then I'm going to get you guys started. I want you to write those right there, and I want you to eliminate x to get started for both. All right, so Maritza's going to enlighten us in regards to the first two. What did you do to eliminate x, Maritza? Multiply the bottom one times negative 2. So this becomes negative 2x, negative 10y, positive 6z, negative 104. Is that correct? Okay. So we don't need this one anymore. Let's see. 2x minus 2x eliminate. We're left with negative 7y plus 7z equals negative 104 and 27, that's negative 77. Hands if you got it to right there. Okay. Next, pass someone, Maritza. Jessica, okay, before I ask Jessica, tell your neighbor what you did to eliminate x on these two. What do we do to the second set to eliminate x? All right. Jessica, go. Multiply times 3 the second equation. Distribute, this is 3x plus 15y minus 9z equals 156. We don't no longer use this one, and then combine, so 3x minus 3x eliminate, so we're left with 16y 7z minus 7z equals 140. Hands, have you got that? All right, that is correct. And now we make our smaller system. Negative 7y plus 7z equals negative 77. And then the second equation is 16y minus 7z equals to 140. So to get started, tell your neighbor, can we eliminate any of those two variables already? Yeah, let's see if they see it. Let's see if they get it. Let's see. Anyone? No? Okay. So 7z minus 7z, they eliminate. Combine these. What is 16 minus 7? 9y equals. What is 140 minus 77? 63. That is correct. And to solve for y, we divide by 9. So y equals 7. All right. Now we need to solve for z in this system. Which equation do we want to use? The top one or the bottom one, now? This one or this one? Top one. So I'm going to bring this one over here. I'm going to write negative 7 parentheses. And we're going to substitute 7 there for y. Then plus 7z equals negative 77. So we have what? Negative 49 plus 7z equals negative 77. Continue, Samantha. What do I do from there? Yeah, we need to leave z by itself, so I do what? Plus 49 to both sides, plus 49. We end up with 7z equals negative 77 plus 49, that's very good, negative 28. Last but not least, divide by 7. Z equals negative 4. So far so good, yes? So now we have a y value, a z value, which is the only one that we're missing. X. So, which shall we use? The green, the pink, or the yellow? The pink? All right, somebody said the pink, so I'm going to bring the pink one over here. And I'm going to leave x by itself plus 5 parentheses for y, negative 3 parentheses for z equals 52. So for y we substitute 7, and for z we substitute negative 4. X plus 35 plus 12 equals 52. Continue, Vince, go. X
minus 35.
Can we combine first, though?
Oh, yeah.
47 equals 52. And then? X equals? Five. All right. So our solution, 5, 7, -4. Solution. Woo! Let's go. 3D. Pretty good, yeah? So once again, what's the purpose of us combining 2 first and then the other 2 over here to make a smaller system and solve for 2 variables? Okay? And then after that, the rest of it is history. All right, from 1 to 5, how comfortable are you with these? 5, 4, okay? All right, so let's move on. So we started with systems in 2 variables, 2 equations, solving using substitution. Then we went to 3D using elimination, and now we arrive to these. Example 7Q, copy this. Solve by graphing. Ha, ha, ha. Ha, 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 ha. Yeah, let's go. The solution given, the system given. Y equals x plus 1, and y equals parentheses x plus 2, close parentheses squared, minus 1. Solve by graphing. Example 7Q. Okay. So, to get started, let's get our coordinate plane going over here. Let's put some tallies. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. X, Y. Okay. So, let's graph the linear function. This one. Do you guys want to use a table, or do you use the y-intercept and the slope? Yeah? All right, I'm going to use red for this one. Where do we start? At positive 1. Place your point at positive 1, right there. And we need more points using the slope. Tell your neighbor the slope for that equation. What's the slope? Yeah, you look at the x. What number is in front of the x? 1, and we make that into a fraction, so that means 1 step up, 1 to the right. So from here we go 1 step up, 1 to the right, plot your point, do it again, 1 step up, 1 to the right, plot your point, do it again, 1 step up, 1 to the right, plot your point, graph your line. There it is. All right, let's go with this one. With this one, we can use a table and do a lot of computation, but that's a little bit too much. So I'm just going to use transformations, since we did transformations all year. So let's make a note. Down here, look up. G of x equals, what is our general rule? A times f, parentheses, 1 over b, x minus h, close parentheses, plus k. Just so that we can focus to see where we're at, okay? Bless you. Bless you. So, before we use these, tell your neighbor what each of the parameters does. What does each of the parameters do to the original function? What does k do? What does h? What does b? And what does a? Talk it over to your neighbor. Fatima's like, I got this, Mr. Q, good. Woo! All right, let's see. Sebastian, K, what does K do? Up and down, that is correct. Up if it's positive, down if it's a negative number, that is correct. What does H do? Let's see, who haven't I picked? Oh, Mel. What does H do, Mel? Left and right. It goes left if we substitute in here a negative number, and it goes right if we substitute in there a positive number. Okay? What does A and B do? Jehu. Stretches it or compresses it. This one vertically, this one horizontally. Yes. Stretch or compress. That is correct. Now that we have that in us, look up. The parent function of this one, if I was to change this to f of x, it would be what? F of x equals x squared. Is that correct? All right, so let me show you the graph for this one. 0, 0, 1, 1, 2, 4. This one is what? 0, 0. This one is 1, 1. And this one is 2, 4. For right now, I'm just going to leave that right there for right now. So picture it right here. We are at 0, 0. We're going to start with this point. 0, 0. Where are we going to move that according to this transformation? Tell your neighbor, where are we going to move that point according to that transformation? All right. Nick, go. 1 down, bless you, and 2 to the left. That is correct. So I'm going to take my invisible point that I have here, and I'm going to go 2 to the left and 1 down and place my point right there. What is my other point? My other point was at 1, 1. So here's 1, 1, invisible. I'm going to move it 2 to the left, 1, 2, and 1 down. What's my other point of the parent function? 2, 4. 2, 1, 2, 3, 4. And I'm going to move that 2 to the left and 1 down. Did you see that? Okay. Now, according to, since it's a parabola, there should be a point reflecting on this side and another point on this side. Is that correct? So on this side, I'm going to place another point, and on this side, I'm going to place another point. So, tell your neighbor the solution to this system. What would be the solution to that system? In case you don't see them, I'm highlighting them in green. Once again, what are the solutions to that system, Mel? -2, -1, and -1, 0, which is that one. But why are they solutions? That's where they intersect. That is correct. These are the solutions, guys. That's how we solve a system using graphing. Is it coming back, some of you? Yes? You're like, oh yes, Mr. Q, I love graphing. All right, so here goes another one. Example 7s. Y equals 2x plus 5 and y equals x plus 3 in parentheses squared minus 4. Graph those using the process we just used and see if you can find the solution. Still have about 3 minutes, at least get started. Pause the video for. All right, so for this one, once again, as you get started, where are you going to start for the first one? You're going to start at positive 5. And what is the slope? 2 up and 1 to the right. That's how you get all your points graphed. And of course, you're going to use the transformation for the parabola, so you can graph that, and so on and so forth. So for home plate, number 6 and number 7, only 2 problems from your study guide. Please, pretty please, with a cherry on top. Have a good one, guys. Enjoy. See you guys tomorrow. Bye.